Hello everybody. Welcome back. We are on to geometric sequences, and these are much like the arithmetic sequences that we've been studying in terms of the types of questions you're going to be answering with them. You've learned what an arithmetic sequence is. Now we're going to do the same things we've been doing with that, but with geometric sequences. You're going to learn to find what's called the common ratio of a geometric sequence and how to write the general formula for that kind of sequence. Okay, now with arithmetic sequences, you learn that those are sequences where there's a common difference between terms. Now, and that involves addition or subtraction, right? You always added the same thing or subtracted the same thing if you had an arithmetic sequence. Now, geometric sequences have what's called a common ratio. And just like we use a lowercase d to represent a common difference for arithmetic sequences, we're going to use the letter r to represent the common ratio in a geometric sequence. And the common ratio is simply what you would continually multiply each term in the sequence by to get the next, because that's what a geometric sequence is when you continually multiply by the same number. Or you could think of it as when you continually divide by the same number as well, but multiplication is a little bit better for what we're going to be trying to do with these sequences. Now, you can see that in this first sequence, if you continually multiply by -4, it will keep getting you the next term in the sequence, right? Might be a little bit tougher to see right off the bat here, but in this sequence, if you kept multiplying by 2/3, you would get the next term in the sequence, right? 6 is 2/3 of 9, 4 is 2/3 of 6, 8/3 is 2/3 of 4, and so forth. And so that number that you would repeatedly multiply by is called that common ratio. Now, here's how you're supposed to get the common ratio. You're supposed to find out what the common ratio is by finding the ratio between consecutive terms, any two consecutive terms, but always do the ratio between a term and its previous term. So for instance here, 8 divided by -2 is equal to the same thing as -32 divided by 8, which is also equal to the same thing as 128 divided by its previous term, -32, -4. So that's the common ratio there, and that's why it's a geometric sequence, is because it has that common ratio. And I'll show you that that works here as well. 6 divided by 9, I'm going to show this a little bit differently because I want to simplify the fractions. That's 2/3, right? That was the second term divided by the second term divided by the first term. Then 4 divided by 6 is 2/3, and then here's the one I wanted to show you more in detail. 8/3 divided by 4 is equal to 8/3 times 1/4, which is also equal to 2/3. So the common ratio there is indeed 2/3. Repeated multiplication is what makes a sequence geometric. Alright, now when you start talking about the general formula for a geometric sequence, and I've got that formula in front of you, though I do want to explain to you why that formula is what it is. And I'm going to do so by making up another geometric sequence for you. Consider this sequence, please. And I hope you recognize that that's a geometric sequence, about as simple a one as you can get, where I'm just doubling each term, repeatedly multiplying by 2, which means that the common ratio for this sequence would be 2. But here's what I really want to show you. What I'm wanting to show you is how you can express every term in a geometric sequence in relation to how many common ratios away from the first term that it is. If you multiply the first term times the common ratio a certain number of times, it will get you every one of these things that you see right here. So for instance, if I wanted to get the first term, I would multiply 1 times that common ratio of 2 to the 0 power, right? You want to multiply 1 times 1 in order to get 1. Then whenever I get to the second term, I'm multiplying 1 times the common ratio twice. Or sorry, 1 time, so times 2 to the first power. To get the third term, I'm multiplying 1 times 2 a couple times, so I'm multiplying by 1 by 2 squared. Then 1 times 2 cubed. So every time I'm multiplying the first term by the common ratio. Just it depends on how many times I multiply by the common ratio. And what I want you to notice is that what the exponent here, how it compares, I should say, to the term numbers. So let me write those term numbers. And what you ought to notice is that exponent right there that goes along with the common ratio is one less than the term number every step of the way. For the first term, that's a 0. For the second term, that's a 1. For the third term, it's a 2. For the fourth term, it's a 3. Always one less than the term number. So, if we were to continue this pattern so that we went out to the nth term, the way we would express the value of the nth term in this expression would be 1 times 2 to the n minus first power. Alright, this exponent is also 1 less than its term number. And that's the way that this general formula works. You always, to find the nth term in a geometric sequence, multiply the first term times the common ratio raised to the exponent that's 1 less than the term number that you're trying to find. Let's see how that works out in practice. What I'm wanting us to do for the next several examples is to find the common ratio and the 8th term of the sequence. Alright, now common ratio. We said we could use any pair of consecutive terms in a geometric sequence to find the common ratio. We just need to make a ratio of a term over its previous term. So I would suggest using the 24 over 40, although it would work with any pair of terms here. And I'm going to write that ratio in simplest terms. Those are both divisible by 8, so 3/5 is the common ratio. And I think you can see how 24 times 3 would be 72, and if I think of that as 24 over 1, 1 times 5 is 5. Then 72 times 3 is 216, 5 times 5 is 25. So indeed, that is what I'm repeatedly multiplying by for this geometric sequence. There's the common ratio. And then to make the general rule, all we've got to do then is say that the nth term equals the first term, which is 40, times the common ratio to the n minus first power. Every time that will work out. Hopefully that's pretty simple. And then, of course, we want to be able to find out the 8th term because that's what the directions told us to do. So, now that we've found the general rule, let's apply it to the 8th term. Let's replace n with 8. That'll be 40 times 3/5 to the 8 minus 1 power, or to the 7th power. Now these are numbers I would not expect you to have to work without a calculator on for sure. So type that into your calculator, and the 3 significant figures, you're going to find that it's about 1.12, that 8th term. Great. Try that for this sequence, please. Alright, again, the first step is common ratio. In this case, that means we're dividing 1.8 by 1.2. Now that happens to be 18 over 12, which simplifies to 3/2. You could have also said it was 1.5, but if you weren't using a calculator, this is what you would do. And then the general rule, general formula then, to find any term in this sequence would be u sub n is equal to the first term 1.2 times 3/2 to the 8 minus first power, or to the 7th power. Again, I would expect you with these numbers to use your calculator to figure out what that actually comes out to, so let's do that. And when you do, you'll get approximately 25.6 for the value of the 8th term. Whoa, you know what? I made a mistake there, didn't I? I wanted to do this first. And just write the general formula for the nth term. And that needed to be an n right there. What I accidentally did was wrote the formula for the 8th term. I skipped ahead of myself. Needed 2 answers here, and I was only giving you 1. There's the second answer right there. So the general rule and the 8th term. Alright, try it here. Makes no difference that each term has a variable here. It's a geometric sequence, and you can tell that by making ratios out of terms with their previous terms. So the common ratio is going to equal 2x cubed y cubed, that's the second term, divided by 2x squared y, which is equal to, well, those will cancel. X cubed divided by x squared is just x. Y cubed divided by y is y squared. Xy squared is a common ratio. And I think you see how if I multiply the second term by xy squared, you see where the x to the fourth and the y to the fifth would come from, and so on and so forth. Alright, so there's our common ratio. Now, for the general term, general rule. Okay, so now that you know the common ratio, you should be able to write the general formula here. It would be u sub n equals the first term, 2x squared y, times the common ratio, xy squared, raised to the n minus first power. Okay, now you shouldn't need a calculator to do this next part. Well, let's find the eighth term. These numbers are easy enough. So you can see I put in 8 for n, and instead of writing 8 minus 1 for the exponent, let me just go ahead and write 7 there. And then remember, to square a product, you square every factor in that product, or in this case, in order to raise a product to the 7th power, I need to raise each factor in that product to the 7th power. So that's going to become x to the 7th, y to the 14th power in there. Whoops. There we go. And then we'll just do the multiplication here. We got 2x to the 9th, y to the 15th power is the 8th term. Alright, so that's how you write the common or the general formula for a geometric sequence and how you use it to find a specific term number. Thanks for watching. We'll do more with geometric sequences later.